Yeah, hello and welcome back. Like I promised in the previous video, we're going to look at the family size distribution into details, where we know that this family size distribution is the number of offspring which could either be 0, 1, 2, 3, and so forth, that each offspring is capable of giving birth to. This is the family size, okay? Yes. And the probability of producing k offspring is denoted by probability that y is equal to k. So the simple notation is p subscript k. As in, if we have probability that y is equal to 1, it means that this is the probability of producing one offspring. Okay? Yeah. So we can look at the PMF of it. So this is y and the probability. So 0 offspring means p0, 1 offspring p1, 2 offsprings p2, and so forth. Right? Good. Great. So let's look at some definitions of the branching process. Let's properly define the branching process. So I'm saying that a branching process is defined as follows. So we are saying that a single individual should begin the process. A single individual should begin the process at time n equal to 0. Every individual lives exactly 1 unit of time, then produces y offspring and dies. All individuals reproduce independently, and individuals 1, 2, 3 all the way to n have family sizes y1, y2 all the way to yn. So I'm trying to say that if the initial individual gives birth to either one individual, 2, 3 all the way to n offsprings, they are saying that these offsprings have the potential of also having their own family sizes, okay, their own family sizes, and this family size for the first individual is going to be y1, the second individual is going to be y2, and the nth individual is going to be yn. So where each yi has the same distribution as y. So I'm trying to say that these are IID family size distributions. So if the y1 follows binomial distribution, that's the family size of the first individual, then the same distribution is going to apply for the remaining individuals in the generation. Okay, yes, and that will be the same as the y, that's the first family size for the single individual at time 0. So I'm saying that let Zn denote the number of individuals born at time n. So Zn, in other words, is a generational size random variable. Okay, so this is the number of individuals that are giving birth to at each generation. Okay, so if you give birth to, if the first single individual gives birth to 3 children, it means the first generation is going to be generation Z1. Z0 is the initial generation, that's one person. So Zn is seen as the generational size, okay, or the size at generation n. Okay, good. So the branching process, like you know, is a stochastic process. So it's a collection of random variables. So Z0, the initial individual, which we all know is 1, and the family size of this one is going to be Z1. So this is the population size at Z1. Z2 is the generational population size at time 2, and so forth. So this collection is what we call a branching process. Let's continue with the definition and see more. So the state of the branching process at time n is denoted by Zn, which I've already said. So which represent the size of the population at time what? At that time. So I've mentioned all this. Let's look at the branching process, how it works. So you see, the process begins with one individual. So the first person gave birth to 3 offspring. So this is Z1. Whatever you see here is Z1. So this is Z1. So this is Z2. You realize that this is Z2. Let's see it. So the first individual gave birth to 3. Out of these 3, 2 were able to produce. Meaning this person, if it's in the case of a human being, is barren. Like that's a barren or impotent. This person or this offspring was not able to produce. You see, so the process has cut off at that end. So but the other 2 were able to give rise to new offsprings. That's 5. So Z2 is equal to 5. Okay, that means that this one is going to give us y1. Okay, this is going to give us y2, and the last one is going to give us y3. So this is going to give us y 3. Good. So y1 is actually equal to what? So this is going to be z0. Okay, so z0 is equal to just one person, this one individual you are seeing here, that's z0, and then z0 is 1, so z1 should be equal to y1 plus y2 plus y3. Okay, you can see that because there are 3 individuals, so z1 is equal to y, the first family size, that's going to be y. So z1 is actually equal to what? Y. That's the first family size, and y is 3 in this case. You can see that y gave us 3 offsprings. Now the family size of this person is this, so y1 is actually this 3. Y1 is equal to 3, y2 is equal to 0 because y2, this second individual, did not produce. Y3 is equal to 2, so that makes z2 to be equal to y1 plus y2 plus y3. Okay, so the third generation is going to be this. As you can see, the population is increasing as we are moving. So these 3 people, I think this person did not produce. The 2 produced. So meaning we're going to have the family size of this person is going to be y1 as well. This person is going to be y2. This is y3. This is y4. This is y5. So it means that y1 over here is going to be 1. Y2 is 0. Y3 is 2. Y4 is 3. Y5 is going to be 2. So when you add all these up, then you're going to get z3. So z3 will be equal to y1 all the way to y5, and that will give us our total offspring number, and that's going to give us somewhere 8. All right, yeah, that's how the branching process works. So don't panic at all. So let's look at some questions about the branching process. What are the major things that we want to study about this probability distribution, or maybe like we want to know about the survivorship or the extinction of this generation as time goes on? Is it that the generation is going to go extinct or is going to survive? So we want to know what are the questions we're going to ask. So when we have a situation that can be modeled by a branching process, there are several questions that we might want to answer. The first one is that if the process is just beginning, we just began with our initial ancestor, so what will happen in the future? What is the future state? Is it going to survive or is it going to go extinct? Right? That's the first question we need to ask ourselves. And by that question, we want to know, or we want to find out about the distribution of our Zn. That is the population size at each generation that we want to study the population on. And to know this, we need to find the mean and the variance of what? Of Zn. Can we do it? If yes, then the probability generation function of family size y can also be found. Yes. Why are we doing this? If the mean tells us the average number of people we have in each generation, so if we know the average number, then it's good. We can know whether the population is going extinct or is surviving. The next question we may ask ourselves is that, can we find the whole distribution of Zn? As in, for special cases of the family size distribution, we can find the PGF, that's the probability generation function of Zn explicitly, but not in all cases. Okay, for some complex distributions, we may find it very difficult to do this. But can we find it? Yes. If it is a yes, then the questions about the future can actually be answered. Then the next is, can we find the probability that the population has become extinct by generation n? That is the probability that Zn is equal to 0. Can we do that? Yes. So if we can find it, then it will help us answer questions about the future. Okay. Yeah, so let's look at the next question, major question we can ask about the future state. If the branching process is beginning now, what is the future state? So we want to find out about eventual extinction. As the population is growing over time, what is the pattern that we are seeing? Is it eventually going extinct, as in every species dying off gradually? That's what we mean by eventual extinction. Do you get it? There's a difference between eventual extinction and extinction. So eventual extinction is like the sequential extinction of the entire branching process. But extinction is like maybe it's with certainty that we've gone off, like everything. So you see that the eventual extinction is like taking the limit as n approaches infinity of the probability that Zn is equal to 0. You see, it's like a sequential thing, something we study over time. Yeah. So can we find general conditions for eventual extinction? Yes, we can find them. So let's say that we're able to find the average number to be equal to 1, or maybe less than 1. we all know that the species we said could either be 0, 1, 2, 3, and so forth. If it's 0, meaning we cannot have 0.5 or something. So if the mean is less than 1, it means that that's approximately 1, because it's 0, sorry, because we can't have 0 point something species, right? If it's greater than 1, we know that there are more than 1 species in the generation, so we can say some certain things about it. Is there a guarantee of extinction that will occur with a probability of 1 or not? We will look at some conditions for eventual extinction very soon. Yeah, so let's look at questions. The second major question, the Galton and Watson, they actually asked. So if the branching process is already in progress, what happened in the past? So in this case, we say that the process has been running, like we know that it has begun. Maybe you are somewhere and you don't know even your root. Okay, we want to trace back to your initial ancestor. Where do you come from? Maybe let's say you are a black American, okay, then you stay in Europe or something, like you stay in America, or maybe you stay in another part of the world, but you're an African. You want to trace back to your origin. So now that is a question that can relate to that. So like, how can we get to the past and know where you are actually coming from? So how many generations do we need to trace back in order to get to your root? That is what we mean. So how many generations do we need to get back to the single common ancestor that you actually came from? Okay, so what has been the distribution of the family size over the generation? Is it Bernoulli? Is it binomial? Is it geometric, and so forth, right? Yeah, so we want to know that. So the third question is that, what is the total number of individuals over all generations up to the present day? What is the total number so far? Yeah, so it is believed that all human beings descended from a single female ancestor who lived in Africa. How long ago? It was estimated approximately 200,000 years ago. Yeah, I don't know how true this is, but that is what I saw, right? Yeah, so let's look at the distribution. Like, I think I'll pause here. Then we'll look at the distribution of Zn also in another video. Thank you so much for watching this video, and God bless us all.